Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. In this video, we are going to continue our efforts in the generation of the finite element objects, because as you know, we are still stuck in the create FEMObjects from STRLines, which needs us to find the sorted nodes, and we started with that. In the previous video, we actually were able to detect all the STR nodes that are on a certain STR line. Now we detected those and we found its t-values, but we are still unable to provide the sorted list of that back because I need the sorted list to generate some finite elements. Now today we're going to try do that and maybe take a look on the generation of the finite elements, and as per usual, the three quick reminders. First of all, this is part of the FEM playlist and it has also a separate playlist. Both playlists are linked on the top right, and of course my dear channel members have access to the source code in its entirety. However, if you're not a channel member, then don't worry, because every single line will be written in front of you. You can write along and you will have the exact same code as mine. So with that being said, and without further ado, sit back, relax, and enjoy the show. Now I know there are a ton of ways of sorting a certain list based on another list, because we're going to sort the nodes based on the t-values, but there is a very easy way of doing it in MATLAB. You see, let me show you something here. This is called the sort command. This is a command in MATLAB. If you just right-click here and ask it to open the help on sort, you can learn a lot of things about this algorithm or this method. You see, one of the commands tells you b and I equals sort of something. Now what is b and I? B is the sorted values and I is the indices of the sorted values. So what I will be doing is I'll open a bracket and say sorted t values. Now to be honest, I don't need it. I don't need the sorted t values, so I will end up discarding it anyway. What I'm interested in are the indices, because I want to find the indices of the final sort. And here I can ask to sort the t values. So now we have the indices that tell you the sorting of the t-values, and I think by default it sorts in an ascending order. So all I have to do is to call sorted nodes, which is the output, is going to be nodes on segment, the unsorted list, and pass in the list of indices that are sorted. Let me show you this in action. So I will put a breakpoint here, I will go to main and run. Now of course we stopped here. If you remember from the previous video, we had nodes on segment, 3 nodes, because let me show you those. Let me show you the nodes on segment, so if you remember that. I double-clicked here. Yeah, we had those nodes, the 000, the starting node, the 005, the ending node of line 1, and the 001.66, the intersection node. So we have 3 nodes, and they have t-values, and you can see the t-values are unsorted, 0, 5, and 1.6. When I ran a sort on them, you can see that the sorted t-values now is 0, 1.6, and 5, and the indices is 1, 3, 2, because the sorted index would be first the element at 1, and then the element at 3, and then the element at 2. So 1, 3, 2 is the indices, and you can see them here, 1, 3, 2. Finally, when he wants to call for the sorted node, let me step. He will give you the nodes sorted correctly. Let me just open it to show you. If you double click on the sorted nodes, those are sorted from start to finish. 000, the start, 001675, 167, this is the midpoint or the intersection point, and 005, that's the endpoint. So that is exactly how we can sort in MATLAB. This is much easier than what you would need to do in other programming languages, so I hope you enjoyed. Now this would end the sorting. I will stop. This is of course useless. I can just put a tilde here because nobody cares about it. Here there is a problem. He doesn't like it because t-values change their sizes every time, and nodes on segment change their sizes every time. Now the problem is, I don't know what the size is going to be, because I don't know how many nodes are on the line. And this is one of the things that MATLAB doesn't like, because he wants you to pre-allocate the storage system. I'm not going to pre-allocate the storage system. I will just suppress it for now, for all files. I suppress this allocation thing. Now, this is not the best way of doing things. I'm going to suppress it anyways, because I know there is some optimization to be done, especially in those things that keep changing size. But I'm not here to go too deep in the programming aspects. If you want to get a really deep dive in the programming aspects, there is a Udemy course on C# where I really go into the deep dive of all those programming skills that you need to optimize code. But here, what I'm doing is I'm trying to provide tutorials that are somewhat not complicated and not necessarily the most optimized. So I have a trade-off between complication and optimization. So I will take this trade-off for now. Okay, so we have the sorted indices. Let's get back. So this ends the STRLine drama here, and we go back to STR controller, because now we should be able to get to the sorted nodes. So let me just run here again the main and see if I do get the sorted nodes. And I have the sorted node. Let me just check what they are. Okay, they are 0. Yeah, they are sorted. Perfect. I have the sorted nodes, and I can do some stuff with the sorted nodes. What do I want to do with the sorted nodes? I'm gonna start creating FEMObjects from the sorted nodes. Between each two of the sorted nodes, I'm going to generate something called FEMBeams, which is a Bernoulli beam. I'm going to use the Bernoulli, not the Timoshenko. This is going to be a Bernoulli beam, and I need to declare or generate two beams because I have a node in the middle, because you cannot have a node in the middle of an element. Elements are between nodes, and you cannot have a node that is in the middle of the element. It doesn't work like that. It needs to be meshed. Now, people like to call it meshing the beams. I kind of don't like the word. I like meshing to be called for plates, where you really see a mesh. But for a beam, I don't know. People like to call it meshing the beam. I like to call it breaking the beam into pieces. So how would I do that? Well, I would need, of course, to run a for loop. So let me put here, first of all, something called fem nodes on segment, or maybe sorted fem nodes. I think I should call this nodes sorted, and this like fem nodes sorted, to kind of keep the flow running. Now here I'm going to declare it to be empty. This is something that MATLAB is going to hate, because I will cyclically change it. But for now, I'll declare it empty. And yeah, I need to start the fem object creation shenanigans. So we are now here, and I'll start creating. So for now, I is already reserved. I cannot use it again. For j equals from 1 to the length of the nodes sorted. What do I want to do with this? First of all, we need to fish out the str node. So str node here is basically the nodes sorted of j. I am fishing out the node. Also, I need a fem node. So fem node is going to equal, I have the corresponding fem node, right? I could just call str node dot corresponding fem node, and it would be working fantastically, because the str node has a corresponding fem node. And I have done this during my str controller stuff, when I said create fem objects from str nodes. So I could call this. Maybe there is a scenario, I'm not really sure. Maybe there is a scenario where I have an str node that doesn't have a fem node. I don't want to run the risk. So you know what I will do? I'll just ask the controller to generate one. So add fem node. Okay? And I'm going to call for strnode.x, strnode.y, and strnode.z. I will explain my thought process behind it in a moment. Let me just stop here and check if everything is fine. Let's open the bracket here. Yeah, XYZ. Okay. See, I'm kind of split opinion here, because usually it happens sometimes that you can lose track in your programming. I remember that in the str node, I have corresponding fem node. And I also remember that in the create from objects from str nodes, I actually created for each individual str node a fem node. So I am almost 99% sure I will simply be able to get the fem node from the corresponding fem node in str node. So I'm pretty sure that I can get, say, fem node equals str node dot corresponding blah, blah, blah. But I don't, the 1% risk is something I don't want to take. So what I will be doing is I will ask the controller to define me a fem node. Now, this is not a problem, because in the add fem node, I have a failsafe. Let me show you. In the add fem node, I have a failsafe that checks if there are any duplicate nodes, and if this fem node has been defined before, it just returns the old fem node. So here, if I do this, I don't run the risk of defining two fem nodes at the same location, because if the fem node has been defined, it will just return me the defined fem node. So I think this is more on the safe side. I just put here a comment to say that alternatively, fem node equals strnode dot corresponding fem node. Alternatively. Anyway, I just be more safe than sorry. I kind of dislike it. By the way, this is not the best programming practice, because inside add fem node, there is a loop that checks all the fem nodes, so that's a place for improvement. And let's do our shenanigans. Fem node, let's do our definitions. So fem node, this is a new, now worst case scenario is that I have a new fem node, so I need to declare everything. So corresponding str node, this is gonna be str node, and fem node dot is master node equals true, and fem node dot is slave node. It's not a slave node, I've talked about this before. Fem node dot master fem node, that's nothing, and fem node dot slave fem node, that's nothing. So this is impossible to be something because it is a master node. This for now is empty because yes, it is a master node, but we don't know if there's a slave node for it or not. When do we have slave nodes? We have slave nodes if we have supports or if we have releases. So maybe we will have a release, and maybe this will become a slave node, but that's something we don't know yet. So we have defined our fem node. Let's store it in the fem nodes sorted. So fem nodes sorted equals the old fem nodes sorted, added to it the fem node. Once again, MATLAB will hate me for this because I am not pre-allocating this. It's just gonna keep copying. This is gonna be a performance drain. Now, if you are a pro programmer, I suggest that you write along all those performance drain as I keep mentioning, because you want to improve on my code, so you will need to highlight exactly where the places are where I note that this is not the best way of doing things, you could do it better. You can basically overtake me and do something even better than me. But of course here, I am to build the skeleton or the construction, and then you can expand upon the structure or the bases that I'm building here. Okay, I need to close this, I need the space. I have fem nodes sorted, we are ready now. Now here, let me just give you a hint. Strado actually checks for line offsets. And if there's a line offset, it does some stuff. But we don't have line offsets here, okay? Now, what we do have is we have releases. So I need to here deal with the releases, and then I need to generate, so within the dealing of the releases here inside it, here I will need to generate springs, and after that I would need to generate fem bar beams. So not fem bar springs, but fem bar beams, the Bernoulli beams. Those two steps would end the generation of the finite element model, by the way. It would not end everything. There is still much more to do, but at least here, if we reach this position, we would have ended the finite element model generation and we would have reached a big milestone. But for now, we're not there yet. Let me just stop here for now because I have declared exactly what I want to do. I need to get back and script my next video to think about exactly how I'm gonna show this for you. So what we have done is we have sorted the STRLines, we have got them out, we started a loop on them, and we made sure that every STRLine has a fem node. If it doesn't, then we add it. I could just set fem node and that's it, but I want to play it safe, so I added it, and if it's duplicate, it will give me back the previously defined fem node. So no harm whatsoever, with exception to some performance harm that I already discussed. So yeah, that's everything I wanted to talk about today. I hope you enjoyed, and in the end, I want to give a fem node sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you find it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.